We're going to start off this video with a couple of definitions. These definitions are of some special points that come up in graphing, and they're going to come up with our linear graphing now. And when you do additional graphing of curves and lines in future math courses, you'll also talk about these special points. The first one is called the x-intercept. And for a graph, the x-intercept is the point at which a graph crosses the x-axis. So when I draw my axes, I have the x-axis and the y-axis, and I'm just going to use a piece of spaghetti to be my line. So let's just say I take a line and I put it on the graph. If I was looking at where that line crosses the x-axis, I would find a point, the point where it crosses. And that point would have coordinates. In this case, the coordinates of that point are 3, 0. Now let's look at a different line. I could have this line here. So if I looked at this line and I followed this line all the way to where it crossed the x-axis, I would find its x-intercept. In this case, it's 1, 2, 3, 4, 5. -5, 0. Let's just do one more. Let's say I had a line right here, and I was saying, where does that cross the x-axis? Where is its x-intercept? And I put a point right there. That point's coordinates would be 1, 0. So if you look at these three examples of x-intercepts, you might notice that they all have a y-coordinate of 0, because when you cross the x-axis, you are not above it or below it, so your y value is always 0. So your x-intercept is the point at which a graph crosses the x-axis, and that point will have a y value or a y-coordinate of 0. Now let's look at the y-intercept. The y-intercept is the point at which the graph crosses the y-axis. So again, if I take my piece of spaghetti and I create a line of some sort, if I look at this line and I say, where would I cross the y-axis? Where is that? And I put a point there. That point would be the y-intercept. In this case, it is 0, 4. Okay, let's do some other examples. I could make a line like this, and if I looked where it crossed the y-axis and I put a point there, that would be its y-intercept. And this particular one has the coordinate 0, -2. And let's just do one more. How about this line here? I look where it crosses the y-axis. That point has the coordinates 0, 1, 2, 3, 4, 5, -5. So you'll note when you're looking at these y-intercept points, they all have an x value of 0. Because when you cross the y-axis, you're not to the right of it, positive x's, or to the left of it, negative x's. You're right at where x would be 0. So when you look at the y-intercepts, they will always have 0 for the x value, or an x coordinate of 0. So these points are going to help us with a second way of graphing. We've already talked about graphing by plotting points, and that was a method where we solved the equation for y, putting the equation in the form y = mx + b. And then we chose values for x, found corresponding y's, and plotted those points. So the second way of graphing a line we're going to talk about is graphing using these x and y intercepts. And there's some steps in the book on page 414, but I'm just going to put an abbreviated version of those steps here. So the steps are: 1, find the y-intercept. And we talked about the way we could do that is we could set x = 0. The second step is to find the x-intercept. And to do that, we could set y equals 0. Our third step is to find one additional point because we always want 3 points when we're graphing a line, because 3 points will make sure that you haven't gotten off on a point. It's kind of a double check. The fourth step is to plot the points, and the final step is to draw the line. So let's take a look at an example of graphing using the x and y intercepts. So here's my equation, 6x minus 12y equals 24. Now when I'm using this method, I do not need to solve for y like I do in the plotting points method. I just leave the equation with whatever form is given to me, and I start by finding the y-intercept. So if I want to find the y-intercept, I know that it has an x value equals 0. So I'm going to set x equals 0. So I take my original equation, but in for x I'll put 0. So I have 6 times 0 minus 12y equals 24. And now I'm going to solve for the y value. So 6 times 0 is just 0, so I get negative 12y equals 24. And then I could divide by negative 12 and solve to get y equals negative 2. So that gives me 1 point, 0, negative 2. And that point is the y-intercept. That's the point across the y-axis. So the second step is to find the x-intercept. So to find the x-intercept, I set y equals 0. That's what that says to do. So I will start again, but this time I'm going to have 6x minus 12, and in place of y I'm going to put 0 equals 24. 12 times 0 is 0, so I just end up with 6x equals 24. Divide by 6, x equals 4. Excuse me. So now I have the point 4, 0, which is the x-intercept. And now I need one additional point. So I can pick any value for x I want to plug in. I see I have an x of 0 and 4 here, so I'm just going to go ahead and try x equals 2. So I'm picking another value for x so I can get a third point. So I have 6 times, and in for x I'm going to put 2 minus 12y equals 24. So I have an equation that I can solve to find a y value. So I'm going to subtract 12 from both sides, and finally divide by that negative 12. And I get y equals negative 1. So that gives me the point 2, negative 1. So I've found the y-intercept, the x-intercept, and one additional point. Now I'm going to plot those points. So the y-intercept is where it crosses the y-axis, and it's the point 0, negative 2. The x-intercept is where the line crosses the x-axis. It's the point 4, 0. And then my additional point was 2, negative 1. So I plot that 2, negative 1. So I'm just kind of labeling to show you where those points are. It's kind of like if I had my piece of spaghetti, it would go right over those points. They are collinear. They look in a line, so that's a good sign. So now I take my ruler to connect them, and I draw a line connecting those points. And when I draw my line, I always put an arrow on both ends to show that that line continues. So that is how I graph an equation using the x and y intercepts.